It is Wednesday, October 8th, and this is for Jake. It's to do a little extra practice with what we worked on with multi-step equations in Algebra 1 class. And so I'm just going to give a problem and explain it, and you can kind of walk your way through it, and then I'll give you another problem and kind of pause for a bit so that you can pause the video, Jake, and then do the problem yourself, and then start the video up, and I'll walk you through the solution, and we'll just kind of do a few of those, and that'll give you some practice for a little bit. Probably, we'll go through enough of them that it might be about 10-15 minutes. So the first problem is 4g minus 2 equals negative 6. 4g minus 2 equals negative 6. So notice that g is on the left side of the equation, and we want to isolate it and get it by itself, so we have to undo everything that's happening around g. So in this case, the 4 is multiplying g, and the minus 2, the negative 2, is adding itself to g. So the easiest thing to get rid of at first is this negative 2 adding itself. So we're going to add a 2 to undo the negative 2. So if we add a 2 to the left, we need to go over and add a 2 to the right side of the equation. So I'm showing that I'm canceling out my negative 2 and positive 2, and I'm left with 4g equals, and the negative 6 plus 2 on the right-hand side would be a negative 4. So now in order to get rid of 4 times g, we're going to do the division. You practiced this yesterday with the multiplication. To undo multiplication, you do the multiplicative inverse, or divide by 4. So we're going to divide by 4 on the left. We must divide by 4 on the right. They cancel on the left, and we're left with g equals negative 1. If we checked it and we put in negative 1 back into our original equation, we would have 4 times negative 1. That's negative 4, right? And negative 4 minus 2, or negative 4 and a negative 2, is negative 6. And sure enough, negative 6 equals negative 6, so it checks. So I'm going to write a problem out for you, Jake, and you can then, I'll say it a couple times so that you can write it out, and then you can pause the video and work it, and then turn the video back on, and there'll be a little bit of a pause, probably 5 seconds or so, and then I'll start working the problem. So the next problem is 5n plus 6 equals negative 4. 5n plus 6 equals negative 4. So I'll pause here for a little bit. You can turn off the video and work it, and then turn it back on, and then I'll work it so you can check your answer. Okay, we have 5n plus 6 equals negative 4. So we want to get n by itself. So we're going to subtract 6 from both sides because of that plus 6, right? We're going to subtract 6 from both sides. Positive 6 and the negative 6 cancel on the left, and we're left with 5n equals negative 4 and negative 6 is negative 10. In order to get rid of 5 times n, we've got to do the division, divide by 5. So we're going to divide by 5 on both sides. 5 divided by 5 becomes a 1, doesn't it? And 1 times n is n, and n equals negative 10 divided by 5 is negative 2. So n equals negative 2. Erase this. And put another problem up for you, and you can work this one. Pause the video and work this one. So here's the problem. 7g minus 14 equals negative 63. 7g minus 14 equals negative 63. I'll pause the video and pick it up back in about 5 to 10 seconds and show you the answer. So go ahead and pause it. All right, so we have 7g minus 14 equals negative 63. You should realize that you need to add 14 to both sides. We have 7g, and we got a negative 63 and a positive 14, so we have to find the difference between 63 and 14. And what's that going to be? 49? Yeah, 49. And it's negative 49 because we had negative 63. There's more negatives, right? And we're going to divide by 7 because we have 7g. 7 times g. We're going to divide by 7 on both sides. And g equals negative 7. G equals negative 7. If we checked it, 7 times negative 7 is negative 49. Negative 49 minus 14, or a negative 49 and a negative 14 combined to be a negative 63. All right, let's step it up a notch and do another kind of a different looking problem. If we have 9 plus y over 5 equals 6. 9 plus y over 5 equals 6. We're still going to use our additive inverse to get rid of the 9, that positive 9. We're going to subtract 9 from both sides. And we have y over 5 equals negative 3. 6 and a negative 9 is negative 3. Now, y over 5, that over 5 actually means division. Y divided by 5. So to undo division, we're going to do multiplication. So we're going to multiply by 5 on both sides. If you wanted to, you could put it as 5 over 1. We kind of looked at this yesterday. We could cancel the 5s, and we have 1 times 1 times 1 times 1 is our y, right? And then we go on the other side, times 5. We have negative 3 times 5 is a negative 15. If we checked it, we'd put negative 15 back up in for y. Negative 15 divided by 5 is a negative 3. 9 plus a negative 3 is positive 6. So there's an example of one with division in it. Let's try one. I'm going to write one down and you try it, and then I'll work it through in just a few seconds. So we have a over 7 minus 3 equals negative 2. A over 7 minus 3 equals negative 2. Pause the video. Take a stab at this problem and then restart your video and I'll work it through for you. Okay, so a over 7 minus 3 equals negative 2. In order to get rid of the minus 3 or negative 3, we want to add 3 to both sides. We have a over 7 equals negative 2, and a positive 3 would be a positive 1. And then a divided by 7, a over 7 is a divided by 7. We want to multiply by 7 on both sides to cancel those 7s. We have a equals 1 times 7, which is 7. We checked it, put in the 7 for the a. 7 over 7 is a 1, and a 1 minus a 3 is a negative 2. All right, I'll give you another one, and you can pause the video. C over negative 3 plus 5 equals 7. C over negative 3 plus 5 equals 7. Pause the video, do the problem, start it up again, and I'll show you the solution. All right, so we have c over negative 3 plus 5 equals 7. We want to get rid of the plus 5 by a minus 5 on each side. We're left with c over negative 3 equals 2. 7 and negative 5 is 2. We want to multiply by a negative 3 because it's c divided by negative 3. You could write negative 3 over 1 to show the multiplication there and how it cancels. So multiply by a negative 3 on the other side. Notice I multiplied by the same number, negative 3, because we want the negative times the negative to become that positive 1 on the left-hand side. So 2 times negative 3, c equals negative 6. If we check our answer, we plug it back in for c. Negative 6 divided by negative 3 is a positive 2. 2 plus 5 equals 7. It checks. All right. Okay, now let me show you another one that looks a little crazy, and I'll do it for you first, and then we'll practice a couple of them. 11 equals 5 plus m all over negative 2. 11 equals 5 plus m all over negative 2. So in this case, we've got a quantity of 5 plus n in the numerator, 5 plus m, and a negative 2 is dividing it into that. So the easiest thing to do is to get rid of that division, that divide by negative 2, or that denominator of negative 2. So to get rid of division, we're going to multiply by negative 2 over 1 on both sides, right? Negative 2 over 1, because see how they cancel? That denominator cancels with the negative 2 over 1. And we're left with a 5 plus m on the right. And then negative 2 times 11 is negative 22. Now this is just a simple one-step equation. We subtract 5 from both sides, and m equals negative 27. We check our answer. We plug that negative 27 in for m. 5 plus negative 27 is a negative 22. Negative 22 divided by negative 2 is a positive 11. So in this case, when we saw division happening to quite a bit of stuff in the numerator position, we went ahead and got rid of that division, that denominator. Eliminate that by multiplying by the reciprocal, or multiplying by that negative 2. All right, so I'm going to give you one to do on your own. 14 equals d minus 6 all over 2. 14 equals d minus 6 all over 2. Pause the video, work the problem, start the video up again, and I'll show you the solution. Okay, we see that we can get rid of the division by multiplying by a 2 over 1. We want to do the division first in this case because that d minus 6 is up there in the numerator position. We can't really add 6 to this without making a mess. So we're going to multiply by 2 on both sides. We get 28 equals d minus 6. We're going to add 6 to both sides, and d equals 34. We check our answer. Plug 34 in for d. 34 minus 6 is 28. Divide it by 2. We end up with 14, and it checks. Here's another one for you, and this will be the last one. 17 minus s over 4 equals negative 10. 17 minus s over 4 equals negative 10. Pause the video, do the work, start the video, and I'll show you the solution. All right, on this one, again, 17 minus s over 4, we want to get rid of that over 4 by multiplying by 4 so that it cancels out, right? So we got to multiply by 4 on both sides. We get 17 minus s equals negative 40. We're going to subtract 17 from both sides. We get negative s. That's the tricky part on this one. Negative s equals negative 57. Because that negative s means there's like a negative 1 sitting next to the s, we could divide both sides by a negative 1, and s would equal positive 57, right? If we plug 57 into our original equation, 17 minus 57 is a negative 40. Negative 40 divided by 4 is a negative 10. It checks, and we did it right. So there's a few problems you could do on your own to practice those multi-step equations and stay caught up with the class. I'll send you another video tomorrow on doing multi-step equations with variables on both sides. Hope all is going well for you, Jake. We miss you. We'll see you soon.